Okay. Um, RFL. Rewrite H and then reflection. Rewrite 2 equals successor 1, 1 equals successor 0, and we're done. One equals successor 0, 2 equals successor 1, reflection, and we're done. Add 0, and we're done. Add 0, and we're done. Start by unraveling the 1. Okay, so 1 equals successor 0, and then add what? And then we're going to add successor. So then we're going to add 0, and we're done. Uh, 4 equals successor 3. 3 equals successor of 2. 2 equals successor of 1. 1 equals successor of 0. Add successor. Add successor. Add a 0. And I think we're done. Okay. Art, addition world. Deduction N with DHD. Okay, that's a base case. Now for the inductive case. I think that does it. Okay. Successor add. Do we induct again, or what is the hint? Well, we have add successor. We have add 0. And we have 0 add. I think we have to induct. Add 0. Okay, that's the base case. Now for the inductive case. What do we have? We have add successor. We've added successor. We'll do the induction hypothesis. And we'll do add successor again. And I think we're done. Great. Add cognitive. Probably induction again, right? Okay, that's done. Now we're going to do a add successor. HD. successor add, and now I think we're done. Okay. Add associative. We have add commutatives right now. Can we use that? Probably not. What is this telling us? Probably to, do we have to induct again? Let me think. It's probably induction. Now comes the fun case. Well, we take here as base case, now have the inductive case. Are we done? Wait, we are done. That was easy. Right, commutative. This is probably the case we can use add associative, and then add commutative B and C, and then add associative backwards. ACB, and now we're done. Okay. Okay, we're now going to do multiplication world. Alright, we probably want to rewrite 1 equal successor of 0. And then we can... What? 1 equals successor of 0 multiplied by successor multiplied by 0, 0 add, and we're done. Well, multiplied by 1, successor, and 0 are not going to be useful. So let's just deduct. Okay, we can have this though. Right, so multiplied by successor. This allows us to use inductive hypothesis. 0 add, and we're done. This is called successor multiplied. We have multiplied by successor. Alright, let us induct. Inductive case. We can now apply inductive hypothesis. Okay, and the rest is just moving stuff around. Multiplied by successor. A times D, A times D. We want to move that around, so it's like add, right, commutative. A times D, successive AD, A times DA, successive D. Okay, we want to do successor add. And I think we're done. Okay. Multiply commutative. Um, Alright, next up, okay. One times m. We have multiplied by one, multiplied by successor, successor multiply zero multiply. I think that's what we should do. Rewrite one equal successor zero. And then we're going to do successor multiply. And then we're going to do zero multiply. And zero plus. Zero add. Okay. So same thing, except we have one multiply now. So we have one multiply, which we use. So rewrite 2 equal successor 1. Successor multiply, 1 multiply, and we're done. Multiply add. Reduction of A. Their hint. Right, induction A with we write 0 multiply. Okay. Multiply HD. Alright, so we've implied inductive hypothesis. Now it's just making the math work. D times B, D times C, D times B. Okay, so we want to add, right, commutative. Okay, so D times B, D times B, D times C, D times B, B plus C in this, right? Add commutative B and C. And at this point, we just want to do associative. Okay. Add multiplication. Did we just do this? We just multiply add. Okay. Multiply associative. Huh, the boss of the multiplication world. Let's just see how this turns out. Okay, we're done. Great. Okay, now let's do implication world. This is the rewrite. Apply tactic. Okay, we're going to apply H2, H1. Successor function is injective. Okay. Rewrite. 4 equals successor 3 H. Successor equal add 1. Okay. Apply successor injunctive add H. Back H. Apply successor injunctive. Okay, now we're going to do rewrite. 4 equals successor 3. We're also going to do rewrite of successor equal add 1. Intro H, exact H. More intro practice. Intro. Apply successor injunctive. Rewrite successor equal add 1. Successor equal add 1. Now it should be done, right? Why are they not equal? Oh, this is exact A. I don't like this. This is going to be exact H. Okay, go with false. So apply H2, H1. Next, we're going to prove that 0 is not equal to 1. Intro H, rewrite 1 equals successor 0 H. Apply 0 not equal to successor H, exact H. Okay. Intro, apply 0 not equal to 1. So we just proved. Now symmetric, exact H. Two plus 2 equals 5. Repeat, successor add. Repeatedly rewrite, successor add. Rewrite 0 add. Apply intro. Apply successor injunctive add H. Apply 0 not equal to successor to H. Okay, that finishes implication world. Alright, let us now do power world. Okay, let's change it back to this. So, this is going to be rewrite power 0. Wait, I am confused. Do I rewrite this? Do I apply this? Current row. Great. That's done. Power successor. Now we're going to want to do multiply by 0. That's done. 1 equals successor to 0. Then we can do a power of successor, followed by a power of 0. Followed by 1 multiply. And now we're done. Problems for all natural. Yeah, let's deduct one. Deduction M is we're just going to do power 0. Takes care of it. This one here we're going to do power of successor. Apply the inductive hypothesis. Multiply by 1. And then we're done. Rewrite 2 equal successor of 1. Power of successor. Power of 1. And now we're done. Induction. Let's try M. Zero plus 0 add power 0 1 multiply. That solves it. Alright, we probably want to do power of successor. Then we want to do successor add. Then we want to do power of successor. And this will allow us to apply the inductive hypothesis. Actually, do we use initial power successor? No, we don't. We should do successor add first. Power of successor. We can now do inductive hypothesis. And now we'll handle the other side. Power of successor. A to the D, A to the D, A to the N, A to the N, and there's A in between. Okay, we need to fix that. Rewrite multiply. Which tactics do we have for multiply? Probably just make it associative first. And then multiply commutative, the A to the N, A. Okay, so A to the D, A to N on both sides. Now we're going to make it like this, and I think this finishes it. Great. Multiply power. This looks like induction on N. Great. Base case done. Now we're going to handle inductive case. We can now apply inductive hypothesis. Now let's go ahead and apply the power of successor. And now we make some math work out. So A to the D, B to the D and B to the D are not together. Which one should we move? I think we should move this one over. So we're going to use I think this thing's rewrite. Okay, and then we're going to do a rewrite of A to the D, A to the D, B to the D, B to the D. Now we have to flip the A and the B. Okay, now we just want to get rid of all the parentheses. Okay, and now I think we can finish. Great. Power to the power. Probably definitely. Power of 0. Great, that finishes it. Base case done. Inductive case. Rewrite. Power of successor. HD. Moral successor. Power of add. Okay, A to the M times T, A to the M. Oh, this is done. Bam. Add square. Rewrite. Power 2. And then we're going to multiply, add, multiply. Alright, now we have to make all of this stuff here match up. So, we're going to aim for a squared, b squared, 2ab. So a squared, b squared. So we want a times b times b. This is going to be add commutative. Alright, and we want to do add associative. Then we want to do an add commutative. Okay, so a squared, b squared, a times b, b times a, and add commutative. A squared, b squared, ab, a squared, b squared, 2ab. Okay, let's get rid of the 2. So rewrite 2 equals successor of 1. Successor equals add 1. Add multiply. 1 multiply. Add multiply. Alright, I think this almost works. So now we want to do this and nope, this is not enough. What? What am I doing wrong? A squared, B squared, AB, AB. What is going on here? Hey, that worked. Yeah, we're going to skip this one. Mainly because this little box here is too small. Alright, we are now going to start Algorithm World. So, let us get started. We need to somehow rearrange this. A, B, C, B, C, A. What theorems do we have? Rewrite could be A plus C. Wait, ACB, this one. We can do could B and C. And then associative. Okay, great. What do we do here? We're doing more moving around. Alright, let's take the hint. Repeat, rewrite, associative to push all the stuff. A, B, C, D. I don't think this is actually enough. Oh, is this? What do we want to do? B, C, D, C, D, B. Alright, so I think we want to do a rewrite of add commutative B, C plus D. Okay. And I think at this point, well, this just lagged. Wait, I should not have typed that. Like, whatever I typed caused huge amounts of lag. Let's get rid of this repeat. Okay, there's a huge amount of lag. I'm just going to reload the page. Okay, did this solve it? This solves it. So, this is where we use simp. Only add left this and add. Okay, great. What do we do here? sim add. Great. Rewrite pred successor of A. Rewrite. Do this on a single line. Okay, that worked. Successor of A is not equal to 0. Control H. Taking the hint. Rewrite H. Great. Now for equality. Taking the hint. I think we just do this here. We do that. Wonderful. It says use decide, so we will use decide. And this is to use decide, so we'll use decide again. 3. Okay, that finishes Algorithm World. Okay, let us now do Advanced Addition. What do we want here? Probably induction on N. We're going to rewrite. Now we have to handle the inductive case. Alright, now I think we just do that and okay, great. Intro, apply, add, A, B, N, and then rewrite this should be exact A1. Great. Add left equals self. Control H. Right, we're going to use the previous one, and to do that we need to make this term here be 0 plus y. So it's, and rewrite the second y, 0 add y at H. Right. And we're going to apply add left, which one do we apply? Add right cancel to x0y and fact H. Great. add right self equal. This is basically the same thing, I think. Um, so I'm going to rewrite. We want the second x to be add 0x. We want to invert it back and at h. Okay. And then we want to apply add left cancel y0x and exact h. Great. Add right equal 0. Probably just cases on A here. And we want to get a contradiction out of that term there. So we want to do rewrite successor add at h, sim at h, apply 0 not equal to successor at h, exact false dot lim h. Now how do we do this? There we go. If a plus, this is, I think, the same as the previous one. So let's do add right equals 0, A and B, B and A. Okay. Add, rewrite, add commutative, exact H. Alright, so that finishes advanced addition world. Okay. Alright, we are now going to do inequality world. This can be just use 0 and we'll just do use x. We're going to do use 1. Okay. We're going to take the difference between the two and add it up with the value that we use. So, cases hxy of d1 h1 plus d1 h1 plus d2 h2. And now we're going to use d1 plus d2. We're going to rewrite h2 and h1, and we're going to easy. Which series? Alright, that's probably it. So let's do cases x. This is one that's easy. And this case here, we're going to we can't do that. let's take a step back and think about this. Oh, case is hx, and we're going to sim at h, and then we're going to do apply add left equals 0 at h, add right equals 0 h, okay, exact h. Let's break up hxy. Okay, and right. So we're going to prove that d1 is 0, which will get us this, and we'll do that by proving d1 plus d2 0. So, and also we're going to do a add 0. Where is this? Okay, why can't we do this? Right, now we're going to do apply, add, left, cancel, at h2. Alright, so we have 0 equals d1 plus d2. And now we're going to do a apply, add, right equals 0, h2. Good. We're going to rewrite h2 at h1. And we're going to do add 0. At h1. Okay. Dealing with OR. Case is h. This is going to be right. This one is going to be left. It's the toughest level yet. If a is a number, then cases a will split into a equals 0 and equals successor b, and don't go left or right until this. Reduction x. I think this is what I want to do. So we're going to go left. So fly 0, or we'll go right. In this case, we're going to go left. we're going to take the value out of that and apply it. So do we not have something that says that just proves this for me already? Right. So it takes the value left. Takes this h of value hv and we're going to use this value v, and then we're going to rewrite hv. We're also going to rewrite add successor add. Right, I think we do the same thing here. We go right, and in case this h was hv, use v, rewrite hv. Okay, that's it. Successor x less than equal to successor y, x less than equal to y. Right, let's just break this up. Okay, and now we're going to just use v. Apply successor. Rewrite the successor add at hv. Okay. If x is less than 1, it's either 0 or 1. Okay, so let's break x up. Left. So rewrite 1 equals successor 0 at hx. And there's some lemma here. I think this is exactly it. Apply successor less successor hx. Apply LE 0 at hx. Rewrite hx. So we'll go right and then rewrite 1 equals successor 0. Okay. If x is less than equal to 2, then equals 1, 2, or something, right? I think we just do the same thing. Case is x. With x underscore, we do left RFL. And then let's rewrite the 2. 2 as equal successor 1 at hx. Apply successor hx. Okay, we're going to go right, left, and then rewrite 1 equals successor 0. This one here we'll rewrite as well, and then we'll go right, right, and we'll rewrite 2 equals successor 1. that completes inequality world. Alright, let's now do advanced multiplication. We're probably just getting ducked on T here. Okay, so now we have 0 less than equal to 0, which is just apply 0 LE. That handles the base case. Now onto the inductive case. Okay, so now we're going to break apart this H and this HD. So we're going to take their difference and add it here for the value we use. So we're going to use D1 plus D2. And we're going to rewrite H2 and then rewrite H1. And now it should just be rearranging stuff around. So A times D, D1, D1, D2, D2, A, and A. Okay, how do we arrange this? We want A, D1, D2, okay. So we can do, let's see, rewrite, this is add associative, alright, and then we'll do an add commutative with add commutative with D2 and A plus D1. Now stuff in the right order, so we'll do add associative, and one more. This should result. Great. I think it's probably best to just break down into cases of B equals 0 and B not equal to 0. So if B equals 0, we can rewrite mol 0 at H. And then this is tautologically true. Okay, we can't apply that yet. Oh, exact H. Wait. Now the case is B is not 0. So success, so B is success, okay, I shouldn't name this B. So B is successor of B underscore. And what do we do here? I think we do this. So now, if successor of B is equal to 0, we can rewrite, okay, and then, so we have 0 equals 0, and then apply, great, equals successor of not equal to 0. Let's just break A apart. So this is tautologically true. This one here is, we're just going to use A1. Okay, that was easy. 1 less than, again, let's just break A into cases. This one's tautologically true. This one here, we'll just use a1. Rewrite 1 equals successor 0. Successor add 0 add RFL. Okay. A less than equal to A times B. Let's just break apart B. So rewrite mul 0 at H, tautologically true. Here we're going to use this is A times A1 plus 1, so we use A times A1. Rewrite multiply this, and that should do it. Great. What lemmas do we have here? Well, what is this? Let's read the hint. We won't use LE mul right. What is LE mul right? A less than or equal to A times B. What? So we want to prove x, we want to use x less than or equal to 1. Alright, let's follow the hint. Have a 2x times y not equal to 0. What is going on? Not equal to 0. Well, we don't apply that. Okay. We do rewrite of H. This is tautologically true. Okay. Now we want to play LE mul right. Okay, apply LE mul right. X times y equals not equal to 0. In fact, H2. Alright. So we have x less than or equal to 1, and we have to prove that x equals to 1. Okay, let's just do cases of x. In this case, we can solve it via mul 0 at H. In this case, we want to prove that hang on. Wait a second. Wait, I'm going to do something else. I'm going to... Now I have to prove that x is bigger than or equal to 1. This didn't really change much. Now I have to prove successor of A is bigger than or equal to 1. This should be pretty trivial. Use A. And we're now going to do rewrite. Okay, with warning, start. What? Okay, finding God's path. If A equals 0. This level proves one strategy is to write both A and B as successor of something. Okay, so there'll be cases A, cases B. Wait, remove the topologically easy case, and then cases B, remove the topologically easy case. Rewrite successor multiply by successor, add successor. Right, and then apply 0 not equal to successor. Okay. It's logically equivalent to the past one, so it should be easy. Okay, so the past one, what is the past one called? Mo not equal to 0. So has H3 equals mo not equal to 0, A and B. Okay, it's right. It is logically equivalent and therefore easy. This one, induction, B with D, HD. Okay, that is a hint. We're going to take it. Okay, the base case is to prove C equals 0. Base case. If C is not equal to 0, okay, so we should be able to get a contradiction out of that. And then apply multiply equals 0 H. Okay, that's base case. Inductive case. What do we want here? Hang on. So inductive base case, inductive case. Successor. Alright, we need to break C up. We need to get a contradiction here. let's see, rewrite multiplied by 0 at h, apply mul equals 0 at h again. Okay. Alright. So we're now going to make a claim. We're going to claim that d equals c underscore, and then we're going to apply hd, and then we're going to get this out of h. So how do we get this out of h? We're going to do multiply by successor, multiply by successor, and then we want to cancel the a. So it's add, write, cancel. Okay, this is not. Add, write, cancel. Damn it, it is it. Why is this not working? A times d plus a times... Oh, I don't do a rewrite, I apply it. Okay, and then now we're going to do exact h. Great, this case is easy. Rewrite h4. I should do it. Okay, last one. Proved helpful in divisibility world. I think I'm going to just break B apart and just analyze different cases and see what happens. This one here is I'm going to rewrite multiply by 0 at h, and then this is tautological. Okay. So now the case when b is not equal to 0, so b equals successor of b underscore, we prove this equals 1. Great, so I think I'm going to just make a claim that b underscore equals 0. And the way I'm going to prove this is that we use h. Okay. We're going to make this a 0 plus a, and then cancel the a. So a times b underscore has to be 0, and then use that. All right. So and rewrite 1, 2, 3. 0 add a at h. Okay, and then we're going to do add cancel right at h. Why can't we do this? Add right cancel. Okay, and then we're going to do multiply equals 0 at h, and then this should be tautologically true. And now we're going to rewrite the and we're going to do 1 equal successor of 0, and we're done. Okay, this finishes advanced multiplication world.